Well, hello, good afternoon. Welcome to class. We're going to go ahead and work on transferring heat today. These are our notes for heat transfer today. So grab your notebook and we're going to record these down the input side of your interactive notebook. And then we'll move back to the lab to work on a little foldable. And that'll be it for today. Well, your essential question for today is, how are conduction and convection different? All right, so we can see here in this little picture that we've got some convection, conduction, and radiation. And in our next slide, we're going to investigate that and draw a little table that differentiates between all three of these modes of heat transfer. So let's go ahead and move on. Okay, transferring thermal energy or heat energy. We can transfer energy from place to place. Well, we can, but energy is transferred from place to place by these three methods: conduction, convection, and radiation. So if we take a look at conduction all together right here. Conduction is a transfer of thermal energy by collisions between particles and matter. Well, isn't that special? That doesn't mean a whole lot, does it? But how conduction works, it's by direct contact. Okay, so if you put your hand down on your desk, your desktop, you can feel that there's not a major difference in temperature change. But if you were to grab the metal part of your desk, you definitely can feel that that metal is conducting your heat away from your body into the particles of the desk. And how that's working is because of these collisions between the particles between your hand and the particles of the desk. Okay? That's how conduction works. It works by direct contact. All right, our next form of heat transfer is convection. Convection works as a transfer of thermal energy in a fluid, which could be liquid or gas, by the movement of warmer and cooler fluid from place to place. Okay, so convection. If you've ever tried to warm your hands over a fire, it's because there's a convection current that is moving the air from warmer to cooler. All right, and that air is moving up and circling around. That's how convection works. The third mode of heat transfer or thermal energy transfer is radiation. And radiation is a transfer of energy by electromagnetic waves or light waves. Have you ever opened up your car on a really hot day and you felt that heat just come right out of the car? Well, the question is how did it heat up? There wasn't a heater on in there. It heated up because of the light energy from the sun, the electromagnetic waves that were beating on the windshield and then just causing that air to heat up. Okay, so that is by radiation. All right, let's look at these three methods of heat transfer in a little bit more detail. Okay, so conduction can occur in solids, liquids, and gases, really in any form of matter where you have particles that can collide with each other. Metals such as iron, steel, which is a mixture of iron and some other stuff, copper, gold, platinum, these are the best conductors of heat, okay? So that's why if you use a metal pan and you don't use a little glove or a sleeve to put on the handle there, it's going to be hot, especially if you're heating it up on a stovetop. All right, so conduction. It is by direct contact. Next, we have convection. Convection occurs in fluids, as mentioned earlier. Liquids and gases are what fluids are. So both liquids and gases is where convection can occur. The rising of a warmer fluid and the sinking of a cooler fluid forms a convection current. Okay, so we see this pan here heating up on the stove, and the warmer fluid, because it's being heated up by the heat source down here, the burner, and it's moving to the top. Well, let's think about that. Why would that move to the top? Well, because as it's heating up, remember our notes from yesterday, the particles are going to expand, thermal expansion. As they expand, their density gets lower, so it floats to the surface, causing these cooler molecules to fall down because their density is higher than what these warmer ones are. Okay, so that's what causes a convection current. Same thing happens in the ocean whenever we have different currents that occur because of the changes of the seasons and geothermal heating, like lava and magma flows underneath the surface of the ocean. It's because of convection currents. Okay, we see here in this this firefighter is crawling on the floor, and there's a convection current. The hotter air is rising to the ceiling. Okay, we see all that smoke rising to the ceiling, and there's been a vent hole made so that it's flowing out of the home, and then the cooler air is displacing that warmer air. There is a convection current there that just automatically occurs, again, because of the change in the density as the air and the smoke and everything is heated up. It floats to the top. The cooler air displaces it because it is heavier and has a higher density. Okay, now let's look at radiation. Alrighty, radiation, it occurs mostly in gases. Well, why is this? It's because in gases there is a lot of empty space. And radiation, electromagnetic waves from the sun or some other sources, that usually cosmic sources or nuclear sources, they can travel without matter. Okay, that's how this energy works. In this example here, we see this car. This car is heating up inside because the sun's radiation is penetrating through the windshield, and that energy is being converted into heat as the particles receive that radiant energy. Okay, our last slide for today, we have some insulators. Well, insulators, well, what are they? What are they first? Well, they are materials in which heat flows slowly. So they're not conductors. Conductors are where heat flows fast. It goes through really easily. So these materials, heat will go through them, but it doesn't go through them very fast. So some examples of materials in which they are insulators, we've got wood, plastics, fiberglass, and air. And here's some pictures of those things. And we see this coat here. Why do we wear coats? Because coats keep us warm. The heat from our body doesn't flow out as fast when we wear a coat. All right. Well, you guys have a great day. Go ahead and get your foldable paperwork from the sub and or Mrs. Witt, and go ahead and get after it. We're going to be classifying different examples of heat flow as conduction, convection, or radiation. And when you get your work done, guys, remember, glue it in your notebook and take a picture of it and submit it in eBackpack so you get full credit. All right, have a great day.